right, properties of chords. Your essential question. How can I use the relationship of arcs and chords in a circle What does it mean to be a chord? A segment that's located 2 endpoints on the circle. Does it have to go through the center? Can it go through the center? What is it? It goes through the center. What's it called? A diameter. So notice it's not angles, it's chords, correct? So a little bit less angles, really no angles at all, mainly chords and arcs, okay? Last time it was angles and arcs, right? Inscribed angle, then you have your arc. Central angle, then you have your arc. Tangents, you have your angles, right? And your arcs. Now it's going to be chords. So it's going to be a lot more segments, and then we're going to have to find the arcs, or vice versa. So there are 4 theorems we need to go through. They have no names. The first one is theorem 10.3. So actually, when you go to do your homework tonight, it is in section 10.3. Just remember that. So we kind of skipped around a little bit. I don't know if you noticed. We went 10.1, 10.7, 10.5, I think. Now we're going to 10.3. All right. And it says in the same circle, or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So theorem 10.3 says in the same circle or congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. Circle. AB. CD. In the same circle or congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So if this chord is congruent to this chord, then I know that this arc is congruent to this arc. Okay? So arc AB is congruent to arc CD if and only if the segments are congruent. So does it work both ways? Yeah, that's why it's if and only if. So it's saying if these are congruent, then the arcs are congruent. Or if the arcs are congruent, then your segments are congruent. Do you understand? So it works both ways. If the chords are congruent, the arcs are congruent. If the arcs are congruent, then the chords are congruent. Make sense? Okay. Theorem 10.4. It says if one chord is a perpendicular bisector. What does it mean to be perpendicular? Perpendicular. What does it mean? This is parallel. This is what? Perpendicular. Why do I put a T? Because it forms a what? A right angle. So perpendicular means it's forming what kind of angle? A right angle. Has to be beautiful and right, yes? Bisector means to do what with it? Cut it in half. So I'm hitting at a 90 degrees, but I'm cutting it in what? In half. If you don't know that, you just did what? You wrote that down. Because I know what it means to be perpendicular bisector. Do you know what it means to be perpendicular bisector? Okay? So if one chord is a perpendicular bisector of another chord, put your food away. Then the first chord is a diameter. Circle. Chord TR. Chord SQ. Ready? If one chord is a perpendicular bisector of another chord. So, if SQ is perpendicular to TR and it's bisecting, which means these are now congruent, correct? Then I know that this is the diameter. Do you understand? What does this really mean? If we have a diameter intersecting a chord, then I know I cut the chord in what? In half. When I cut it in half, is it congruent? Yes. Okay. So if SQ, segment SQ is a perpendicular bisector of segment TR, then segment QS is a diameter. So far, chords have been what? What? I thought I heard it. No. What do I see about the chord? It's what? It's congruent. What did I see about theorem 10.3? They're congruent. Do I see a pattern here? Okay. This is the converse. So this is the opposite of this one. Okay? It says if a diameter. This one's not telling you have a diameter. It's saying at the end it is a diameter. This one says if you have a diameter. So if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So if the chords are congruent, what do you know about the arcs? What do you think is happening to the arc? No guesses? Okay, I'll draw the picture. F to D. Call that C. Call that E. Call that G. Call this point here H. Call this perpendicular. Yes? So if a diameter of a circle is perpendicular to a chord, did it say anything about bisecting right now? No. But I know if it's a diameter, then it's bisecting the chord. So I know that it's going to make it equal anyways. Oh, my earring. Oh, it's still in my hair. Oh, is that you, Alex? Is that you? Turn it off. So if segment EG is a diameter and segment EG is perpendicular to segment DF, So in other words, I have a diameter and it's perpendicular to a chord. Got it? Then, what is happening? Then I know that segment HF is congruent to segment HD, and I know the arcs are congruent. If this is the diameter and it's perpendicular to this, I now know that this piece and this piece are the same. I now know that this arc and this arc are the same. Make sense? Question? Okay. Next theorem. Theorem 10.6. This unit. In the same circle or congruent circles? Two chords are congruent if and only if they are equidistant. What does equidistant mean? Same distance from the center. Circle. I'll let you draw the picture and then I'll talk about it. Ready? Okay. What does it say? It says, you have two chords, and they are congruent. First of all, they're going to be intersecting these at a right angle. What I'm saying is that this chord here is going to be congruent to this chord here. Got it? So what we're saying is that these two chords, AB, will be congruent to CD if and only if EF equals EG. So these are equal, these are equal. If these are equal, these are equal. Make sense? If I'm far away from here, this is 5, and this is 5, and this is whatever this one is. Got it? Does that make the arcs the same? Yeah. Because that's what the other theorem on the other side, right? Okay. What do you think F and G represent? Perpendicular bisector. So if this is a perpendicular bisector, that means that this piece is the same as this piece. Okay? So this one's kind of putting them all together a little bit in one picture. Questions? It's example time. Does my picture have to look pretty? Can I assume anything from the picture? No. Because apparently some people like to say, well, that looks like it's equal. You don't get to look, you have to know. Got it? All right. Those are numbers. Those are not letters. Understood? Those are numbers and not letters. If you solved it, then go ahead and check with somebody. You should be able to solve it. If you're thinking that long, you're overthinking. Ready? Okay, who has an answer? Only like 6 of you have an answer? What do we think the answer is?
110.
Good job. Why?
Because it's like an error.
What's congruent? A, B, and B, C are congruent. These are the same. If these are the same, then these are the same. And I know this is 110, so guess what? It's also 110. Was that hard? No. Did it? Once again, is this common sense? Yeah. How many of us lack common sense sometimes? Yeah. You know what's funny is usually the more book smart you are, the less common sense you have. Who said that? You? Who said that right now? Pedro? Oh my gosh. He said that's good for you. Oh, that's TJ. Yeah, usually the more book smart you are, the less common sense you have. Why? I don't know. Just seems to be. That problem was easy, yes? Yeah. Dun, dun, dun. How about I leave this here and then I ask you the questions? Because what's happening is a lot of you look at the problem and then get what? Get confused. So I'm going to ignore the question for now. I want you to do what you know by looking at this problem. Anthony's back. What do you know by looking at this problem? Thank you. No, it wasn't. That's all we're doing is circles.
It had two chords.
Yeah, but it had angles. This one doesn't have angles. This one has arcs. There's nothing I'm doing. Lacks common sense. Who can tell me what they did? Who thinks they have X? Okay, what do you have? What did you know, Jaime? One thing you know. 9? You say 9 or 90? 9? No. No. They're perpendicular, and I have a what? That means to be perpendicular, guys. Starts with a D. Diameter. And it says if you have a diameter and a perpendicular, you have now done what to that chord? You've cut it in half. If I've cut it in half, then I know that this chord and this chord are the same. And if the chords are the same, then the arcs are the same. So what did you do with those? Set them equal to each other. If you didn't do that, you're what? You're doing it now. Yes, you were wrong, but now you're doing it. So 9x equals 80 minus x. What do you do to solve this? You add x to both sides, and what do you get? 10x equals 80, and dividing x equals what? 8. Wonderful. What should I do with 8? Plug it in. So let me change the color. So this is 9 times 8, which is how much? 72 what? Degrees. What should this one be? 80 minus 8, which is also what? 72 degrees. You good? Okay, now here's the questions. Question 1. What's the measure of arc CD? Question 2. That's a D. Sorry. What's the measure of arc DE? Question 3. What's the measure of arc CE? What's CD? 72 what? Degrees. What's DE? 72 what? Degrees. What's CE? How'd you get that? 72 plus 72, which is 144 what? Degrees. Do you notice how I could solve this whole problem with just solving for x? Okay? You guys have to kind of ignore what it's asking for the most part, right? If I ignored this, I didn't even want to know what it meant. I could solve for x by what I know, I can plug in what I know, and then I can go from there. Do you understand? All right, let's do one last one. Dun, dun, dun. We have QR. Shh, we need to stop talking. We have ST. Circle C. This is a U, and that's a V. I'm going to tell you that ST is equal to 32 degrees. I'm also going to tell you that CU equals CV, which is 12. I want you to fill in everything you know about the circle. Okay? Make a note of what you filled into, whether it's circling it or whether it's changing the color or whether you highlighted it. Something to show that you found all of those pieces. What do you know? What did you fill in? You filled in CU is what? Okay, what else did you fill in? C but is also 12. What else did you fill in? ST was how much? 32. That's for the segment, not for the arc. So what do I know? Oh, so QR is going to be 32. Why? Why are they congruent? Not parallel. The what? What's equidistant? The center. The center is equidistant from this to the chord. The chords are equidistant from the center. Do you understand that? Equidistant, how do I know they're equidistant? They're both what? They're both 12. So they're both 12, that means they're equally as far, yes? So if they're equally as far, then I know that this is going to be the same as this. True? Okay, so what's the questions? Find QR. Oh wait, did you find it? How much was it? 32, wonderful. Not degrees, it's just 32. Then it says find QU. Why 16? Why is it half? Because it's a perpendicular bisector, so it's cut it in half. So what are we dividing? 32 by 2, which is what? 16. Is that better? So what I want you to do is when you take your quiz or your test, almost ignore the question. Right? Did you see what I did? I filled in everything I knew. If I could have kept going and said this is 16 and this is 16, right? I could have done that. But if I know this and I know the rest of it, then I can find this to be really easy. Right, Victor? Yeah. Leave it away. What are we doing? Okay? Make sense? Questions? Okay, your homework. Write it down. Geometry book. Or did I text you guys? I don't know. I wrote it down too, but I don't remember. 667, numbers 3 through 14, 16, 17, page 670, numbers 1 through 4. This is review. This is the new stuff. Got it? On some of these questions, I think it's like 16 or 17, or maybe it's 13, 14, I don't remember. It's asking you, what do you know? It's not really a math, you can stop it. It's not really like math, like where you're solving it. It's like, what do you know? Well, I know that this is a perpendicular.